Hello, RISE team. My name is Kshitij, and my study is based on comparison of performance of data imputation techniques for numeric and categorical data. My mentor is Professor Nick Brown for College of Engineering. So the background motivation goal for this particular research is that in a standard machine learning pipeline, we'll have a data set which may have a lot of missing values or the data that is collected in real time. So this type of missing data can either be, missing at random, completely at random, or it could be, missing not at random. In my case, I'm working with the missing completely at random scenario. So as you can see, the missing values are basically the ones which are maybe empty in, say, the salary column. So this needs to be imputed or filled with the approximate closest value that is possible. So currently conventional methods that are being used to handle the missing data is mean, median, and kind of an imputation, which is to take an average or the most frequently occurring instance in a particular row and imputing that missing value, that value. So what my method is to basically do a model-based imputation, which is basically use different algorithms and predict the missing value by fitting the particular data with respect to the model and getting the imputed values in place of those missing values. And I'll be doing this by removing 1, 5, 10, or a percentage of arbitrary data from specific important columns, and then perform data imputation, and of course gauge the performance by performance metrics formula that will be showing later. So the algorithm that I'm basically using is the k-nearest neighbors, as you can see, and the multiple chain equations. So the k-nearest neighbor is basically, they're figuring out the nearest neighbors that can be for a particular missing value, say 5 or 3 neighbors that are nearest to the particular value, and predicting the value which is closest to that. So it's a very effective technique, better than the mean imputation. The multiple imputation by chained equations is it's also called MICE. So this algorithm is based on basically treating the missing value wherever it is in a particular column to be treated as a target column, and then using it to predict the target column with respect to the subset of the data that is inside the data set. So it's basically predicting one column based on the other columns that are present. And you do this for each row, each value, and then collaborate the entire result. So not diving too deep into it, but this is generally how it works. So in terms of the products and findings with respect to my research up until now is that the performance metrics I'm evaluating based on the percentage of error, which is the absolute difference between the actual and the observed, finding a percentage of it, and then taking the average error for the entire number of rows that are present. So, and finally, my conclusions and next step further is that, I'll be benchmarking this particular technique with large number of data sets, probably from 10 machine learning benchmark data set, and giving a confidence interval to the user with respect to which model is the best for particular imputation. So yeah, that's my research up until now. Thank you for consideration of my abstract.